Okay, we're here for Notes 9B for the Math 4 course. And one of the things we're going to learn about today is the z-score, which is kind of taking the idea of the mean and the standard deviation to the next level, like the meme says. Z-score lets you know how far you are from the mean with your score in terms of standard deviations. You know, the z-score will tell you whether you are one standard deviation above or below, or two above or below, you know, that sort of thing. And so if nothing else, the z-score is there to compare you to the rest of the pack, as it were. Now, where this comes in handy is when you've got two different tests that you're not sure whether you're dealing with apples and oranges or not. And so the z-score gives you an idea of, you know, how did you do compared to the rest of the class? You know, you did a little better on this test than you did on that one compared to the rest of the class. So that's kind of what the caveat of the z-score is about. All right, so turn my pen on here. A z-score tells a person how far a raw score is from the mean of the population in terms of standard deviations. That's what I was saying there a minute ago. Another name for the z-score is the standard score. Now, that term you've probably heard a few times before. And you're seeing the formula there, which looks like something out of Math 1. At this point, I would venture to say we're not going to be dealing with Desmos with this particular section because it's going to involve some very basic algebra. So let's see what we're talking about here. First, let's start with the score and find out what the z-score is. So if the formula goes something like this, and we're going to plug in, z-score is what we're trying to find. The score is 54 in this particular case. That's Sam. And I apologize that I didn't have the more creative names like Egbert and Filbertina. I just kind of grabbed this from another source and saw that they were good problems and kind of ran with it. And maybe I'll change the names for next year. But anyway, your mean is 76.2 and your standard deviation is 10.1. So by the time you plug that into your handy and dandy little calculator, you should get something like negative 2.198 and some change. So we're just going to call that negative 2.2 z-score. And what that is saying is that Sam's score was less than the mean. It was less than one standard deviation below. It was less than two standard deviations. It was actually 2.2 standard deviations below. Now, you know, when you take the 76.2 and you subtract the 10.1, and you figure that, you know, minus one standard deviation would be 66.1, and minus two standard deviations would be 56 even, and Sam scores a 54. He's even below that. Now, I would remind you of the empirical rule. The empirical rule said that between plus or minus two standard deviations, that's where 95% of the data should live. That means that outside of two standard deviations, there's only 5% of the population that lives there, and we're talking about a little piece up at the top end and a little piece at the bottom end. And so you cut that 5% in half, and you've got 2.5% on either end. And so what this is looking like is that Sam was a part of that 2.5% at the very bottom of the scale. So he was not one of the stronger scores that you had that day. Now, on the other hand, we have Ross, who scored a 79, and we will use the same kind of numbers here. The mean is 76.9. This time we can tell we're going to get a positive number out of this. As it turns out, let's see, you punch this into the calculator, and you should get 0.277 and some change, which basically we're just going to round it to 0.3. Most of the time, you usually don't go more than one decimal place with z-scores. I'll do 2 decimal places later because the decimal actually stops there without having to be rounded. But most of the time, if you've got a big, long, ugly decimal, just round it to 1 decimal place. And this is their z-score. Now, understand what this is saying about Ross's score. This is saying that Ross was above the mean. He was slightly above the mean. As a matter of fact, if you go and add 10.1 to the 76.2 and you get 86.3, he was a lot closer to the middle than he was to 1 standard deviation above. And it shows in his z-score 0.3, that's like 1/3 of the way to 1 standard deviation above. So he was actually living closer to the mean than he was to anything else on that graph. All right, so that's what happens when they give you a score and they say, what was the z-score? Now let's try that the other way around. Let's say that you have a z-score and you're trying to figure out what was the raw score. We can still use the same formula and plug in what players we have. X minus mu over sigma. And let's see now, we will plug in z is 1.2. X is the thing we don't know. Our mean is 120, and the standard deviation is 20. Now, at this point, we have a nice normal algebra equation like you would solve out of Math 1. Get x by itself. Well, I'm going to have to deal with the 20 first. So these guys cancel out. And I'm going to wind up with 24 on this end. And I'm going to add the 120 to both sides. And that's going to give me 144 here and x there. So that tells me a textbook that's in with a z-score of 1.2 is probably going to cost 144. Now think about this. The mean is at 120. A standard deviation above is going to be 140. That's 1 standard deviation above, and 1.2 standard deviations is 144. Yeah, that kind of makes sense. Sometimes it's not a bad idea to go back and check your work that way and just kind of, look at it and say, does this answer make sense with what I know about standard deviations? Now, we're going to try a textbook that was negative 2.1. So we're going to do the same thing. Z goes here. X is what I don't know, minus the mean over the standard deviation. And to get x by itself, I'm going to multiply by 20. This is going to give me negative 42 on this end. The 20s cancel out. And so all I need to do is add 120 to both sides. And I'm going to wind up with 78 here and x there. All right, think about it. Negative 2.1 is the z-score. So if I started from the mean of 120, negative 1 standard would be 100. Negative 2 standard would be 80. And this supposedly lives just beyond that, which 78, sounds reasonable. Okay. Now, the last one here is where we have 2 different tests, and we're trying to figure out which one did she do better on, compared to the rest of the class. And so let's work the chemistry test first. All right, we want the z-score, which is her test score. She made 78 on the chemistry test. The mean was 68, and the standard deviation was 8. That's going to give me a 10 on top. 10 over 8 is 1 1/4. So that's going to be my z-score for the chemistry test. Now, let's do the American history. Here, the z-score is equal to the 81 that she scored, minus the mean, which was 73, and the standard deviation was 7. Well, that's going to give you 8 on top. 8 over 7 is going to wind up 1.142857 repeating. 1.142857, 1.142857. Weird thing about fractions involving 7 on the bottom is they have a weird repeating pattern. It's worth looking at someday. All right. So when we ask which one was better, well, this one seems to be the higher of the two scores compared with the mean and the standard deviation of the rest of the class. And I guess that is it for the notes. You'll have the worksheet and the worksheet video to help you prepare for the Kahoot quiz with the next class.